Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of Physics Wallah. My dear students, I welcome you all to NEET Selection Express. And over here, we are now covering today in this particular session about atomic structure or the structure of atom. In our previous session, we had covered the questions based upon the chapter mole concept or some basic concepts of chemistry. Now, in this particular session, we are going to solve questions based upon this particular session. And as you all are aware that we were doing previous year questions and also the most important questions. So, let us proceed. But before going to that, let me tell you one thing. It is perfectly fine if you lose. It is perfectly fine if you lose. It is okay if you need a break. It is okay if you need a break. But it is totally shameful. It is totally shameful if you don't learn from your mistakes. It is perfectly fine if you fail. It is perfectly fine if you fail. It is okay if you need to cry. It is okay if you need to cry, but it is totally shameful. But it is totally shameful if you give up and never try. If you give up and never try. So try more and more, harder and harder, and you will automatically see your progress. Okay, so practice makes a man perfect. You all are aware of this quote, right? So until and unless you won't practice, you won't progress, right? So students, let us start this session with a beautiful smile. Now, I am going to bring the previous year questions and the most important questions with regard to your chapter, Structure of Atom. The very first question is in front of you. I shall be providing you 2 to 3 minutes in order to solve the question. Then I will be solving all the questions over here so that you can match your answers. If the answer is correct, then it's well and good. Give yourself, marks accordingly. Give yourself 4 marks if the question is correct. If it is incorrect, then you can subtract 1 mark, right? So the very first question is, from the following pairs of ions, which one is not an isoelectronic pair? Okay, now you have certain options over here. Let me tell you. A option is provided as Fe plus 2 Mn plus 2. B option is O2 negative F negative. C option is Na positive and Mg positive Mg plus 2. D option is Mn plus 2 Fe plus 3. I want you all to solve this question first by your own. Try to solve it by your own. Then I will tell you the solution. You can pause the video. Try it once. Now students, look over here. They have told which one is not an isoelectronic. What do you refer to as isoelectronic? Where we see total number of electrons should be same. Okay. So we can write over here same number of electrons. Same number of electrons. So you have to find a pair which are not isoelectronic to each other. If I look up to the very first A option over here, it is Fe plus 2. Now, what is the atomic number of Fe, students? The atomic number of Fe is basically 26, right? So 26 is the atomic number. When it is a neutral species, the atomic number is equivalent to number of protons and number of electrons. I am talking about neutral species. Okay. Sorry. If I talk about only Fe, then then Fe is a neutral species. Okay. Atomic number is 26. So atomic number is equivalent to number of neutrons, number of protons and number of electrons. That means electrons is 26. But now if I will talk about Fe plus 2, that means what? That means what? You are going to subtract 2 number from here. You shall get how many electrons, ma'am? 24 electrons. Okay. Now if I talk about Mn plus 2 over here, okay, in this particular thing, if I talk about only Mn, let us talk about only Mn, my dear students. If I'll talk about only Mn, what is the thing again arise in your mind that, ma'am, how many total electrons are present over there in the case of Mn? What is the atomic number for Mn? The atomic number will be equivalent to number of protons, will be equivalent to your number of electrons. For I would say a species which is neutral. So its atomic number is 25. That means it has 25 electrons as well as 25 protons. Okay. But if I talk about Mn plus 2, if I'm talking about Mn plus 2, here this is about Fe plus 2. Here I'm talking about Mn plus 2. Plus 2, that means we are going to subtract now 2 electrons. subtract two numbers so that we can get electrons. That shall come out to be 23 electrons. Are they same? No, ma'am. Hence our option number A is the correct answer, right? Still we will be solving the other options as well. If I talk option number B, oxygen. See, basically this is O2 negative written and this is F negative written. Kindly correct it, okay? It is not O at the base 2, not oxygen molecule, it is oxygen atom. So over here it is oxygen. The atomic number for oxygen is 8, hence it has 8 electrons. But if I talk about O2 negative, see, when there is a negative charge you are going to add it, when there is a positive charge you are going to subtract it. So there is a negative charge, that means you are going to add this 2 number over here, you shall get 10 electrons over here, right? Now talking about fluorine has an atomic number 9. That means 9 electrons, but again we are talking about F negative negative charge, so we are going to add 1. That means how many electrons, ma'am? 10 electrons. In which case? In F negative. In which case? In O2 negative. Yes, so they are same in number, hence they are isoelectronic to each other. Let us see option number C over here. Sorry. In option number C, if I talk about Na basically has an atomic number 11. That means 11 electrons are there. But if I talk about Na positive, that means what will happen? We are going to subtract 1, then we are going to get 10 electrons. Yes, yes, ma'am. Okay. If I talk about Mg plus 2, again Mg, magnesium has an atomic number 12. That means 12 electrons. But if I'm talking about Mg plus 2, that means what we are going to do? We are going to subtract 2 and we are going to get our electrons. That is 10 electrons, right? Okay. So again they are equal in number. That means they are isoelectronic to each other. Now let us see the D part. Again Mn plus 2. For Mn, the atomic number is 25. So the number of electrons is 25. But if I talk about Mn plus 2, we are going to now subtract 2. That means 25 minus 2 is 23 electrons, right? Now if I talk about Fe plus 3, if I talk about only Fe, atomic number is 26. But if I talk about Fe plus 3, if it is plus 3, we are going to subtract 3. That means 26 minus 3. That tends to be 23 electrons. Again, they are equal in number. That means they are isoelectronic. So, which of the following is not an isoelectronic species? That is going to be our option number A. Hence, answer comes out to be option number A. Is it clear to you, people? Can we move on to the next question of ours if you have done this? Shall we move on to the next question of ours? Yes, my shimmering stars. Okay. Now comes the second question. The number of protons, neutrons and electrons in this species are. They are asking you number of neutrons, protons and electrons. It is a very simplest question, students. If you know this, these all are previous year questions which I am showing you. You can even match them. They are the previous year questions that are generally asked. Now, see, basically here it is written 175 and here it is written 71. If I talk about any element X, okay, its mass number is written over here, which is represented by capital A, and its atomic number is written at the base, represented by Z. Let me tell you what is mass number A. Mass number is equivalent to number of protons plus number of neutrons, okay? And for a neutral species, if I talk about a neutral species, number of protons is equivalent to Z, that is atomic number, and is equivalent to number of electrons for a neutral species, right? When there is no charge provided. Now let us solve this particular part over here. We have been provided with this. This is what? This is Z. This is Z. Now there is no charge given. That means Z is equivalent to number of protons. It is equivalent to number of electrons. Now what is left over is neutrons. How to calculate neutrons? You all are aware that mass number is equivalent to number of neutrons plus protons. Mass number is this. A is equivalent to 175, right? So if mass number is 175, A is equals to N plus B. A is 175. Neutrons we need to calculate, but protons is how much? 71. Neutrons will be what? 175 minus 71. So it tends to be 104. Neutrons came out to be 104. So first of all they asked about protons. Protons is 71. Neutrons 104. And electrons again 71. So our option number A will be what? Our correct answer. Option number A will be what? Our correct answer. I guess this is clear to you, people. If it is clear to you, kindly write it down so that we can move on to the next question of ours. Okay, now comes your next question. Be plus 2 is isoelectronic with which of the following? Beryllium plus 2 is isoelectronic with which of the following? A is H positive, B is Li positive, C is Na positive, while while D is Mg plus 2. Okay, so if I talk about Be plus 2, see, hydrogen, helium, lithium, beryllium, atomic number is what? 4. Atomic number is what? 4. Z is what? 4. Now if I talk about only beryllium, if Z is 4, what will be isoelectronic? We are again talking about iso. Iso refers to as same. Electronic refers to as electrons. Electronic refers to as what? Electrons. Same number of electrons. Electrons for a neutral species is equivalent to atomic number is equivalent to number of protons we have just seen. That means electrons over here is 4 for only beryllium. But if I talk about beryllium plus 2, again, if it is a plus 2 charge, we are going to subtract it. So 4 minus 2 comes out to be what? 2. It comes out to be what? 2. That means now we have to check which of the following has electrons 2 in it, right? Okay. So one by one we are going to see. If I look up to H positive, hydrogen has an atomic number 1, but if it is written plus 1, we are going to subtract 1. We are going to get 0 electrons over here. Now let us talk about the B option, Li positive. Now hydrogen, helium, lithium, 3. So lithium has an atomic number 3. That means total electrons 3 because for a neutral species. But if it is plus 1 written over here, we are going to subtract and we are going to get 2. Okay. Now let us talk about C option, that is Na positive. If I talk about C option, Na positive, Na basically has an atomic number of what? 11. Atomic number is what? Atomic number is 11 over here. So for this case, what we can do is, here is plus 1 charge written. So now when there is a plus 1 charge, we are going to subtract 1. Yes. So basically how many electrons over here? Now students, over here 10 electrons, right? Now let us see the D option that we have. In D option, it is Mg plus 2. Now what is the atomic number for magnesium? The atomic number, ma'am, for magnesium is 12. Now again, if it is written plus 2, what we are going to do? We are going to subtract 2. What we are going to do? We are going to subtract 2. Again, they came out to be 10. Now they have asked in the question that beryllium plus 2 is isoelectronic with which one? If beryllium plus 2 I am talking, they have 2 electrons. It shall be isoelectronic with 2 only. So that is option number B. So option number B will be our correct answer. Is it clear? Kindly write it down so that we can move on to our next question. Yes? Yes? Okay. The ion that is isoelectronic with CO is, the ion that is isoelectronic with CO is A option is Cn negative, B option is N2 positive, C option is O2 negative, and D is N2 negative. Okay. Now let us see one by one. Again, iso refers to as same, electronic refers to as electron. First of all, for the case of CO, we will calculate. What is the, they are neutral species, so their atomic number is equivalent to number of electrons. For carbon, what is the atomic number of carbon, students? Yes, 6. Plus, what is the atomic number of oxygen? 8. So it comes out to be how much electrons? 14 electrons. Now let us see all the options over here. In the very first option, we have been given Cn negative, right? So again, carbon is there, so 6 plus. For nitrogen, atomic number is 7. But there is minus 1 charge. If it is minus 1, we are going to add 1. What it will be? 6 plus 7 is 13 plus 1 is 14 electrons. Now let us see the B option, N2 positive. Nitrogen, we know it is 7 electrons. 2 nitrogen to 7 into 2 plus 1 charge is given. So we are going to subtract 1. What it shall be? It shall be 13 electrons. Now coming to the C option, it is O2 negative. For O2 negative, for oxygen it is 8. For oxygen it is 8. Now it is minus 2. So we are going to add 2. That comes out to be your 10 electron, right? Now comes your D option, that is N2 negative. For nitrogen it is 7 electrons. For 2 nitrogen it shall be 14, right? And it is minus 1 written, so we are going to add 1. So it comes out to be 15. Which of the following is isoelectronic, students? 14 electrons, 14 electrons. That means, ma'am, option number A will be our correct answer. Option number A will be our correct answer. Is it clear to you, people? Can we move on to the next question of ours if it is clear to you? Yes? Okay. Now comes next question. Which of the following series of transition in the spectrum of hydrogen atom falls in the visible region. Okay, A option is bracket series, B option is Lyman series, C option is Balmer series, and D option is Paschen series. So what do you think, students? It will fall in which category? It will fall in which category? It will fall in Balmer series. Which series, ma'am? Balmer series. So option number C is going to be your correct answer. Option number C will be your correct answer. Kindly write it down so that we can move on to the next part. Kindly write it down. And if you want which series, like this is for visible one, no? This is for visible one. If you're talking about IR1, so Paschen and bracket, in Paschen and bracket, you are going to see IR1. And if you're talking about UV, okay, if you're talking about UV region, that will lie in Lyman series, right? So visible region will lie in Balmer series. Great, okay. Now let us see the next question. The next question is, the value of Planck's constant is 6.63 into 10 raised to the power minus 34. The speed of light is 3 into 10 raised to the power 17 nanometer per second. Which value is closest to the wavelength in nanometer of a quantum of light with frequency of this much? Now, if you remember, there is a very general formula that is used over here. There is a very general formula. Lambda is equals to C by V. Lambda is equals to C by V. Very simplest formula, students. How you are going to apply it? See, what is C over here? Speed of light, that is 3 into 10 raised to the power 17 nanometer per second. What is V? Frequency. Frequency is, ma'am, 6 into 10 raised to the power 15. So we are going to solve it. 3 2s are 6. Then this will go above. What we will get? This will be 100 by 2. That means 50. So our answer will come out to be what? Option number A, that is 50. Answer shall come out to be what? Option number A, that is 50. Yes, is it clear to you? Is it clear to you, students? Was it a simple question? Shall we proceed to the next question of ours if it is clear to you? Okay. Now comes the next question. The energies E1 and E2 of two radiations are 25 electron volt and 50 electron volt respectively. The relation between their wavelength will be. Now, here you have to tell the relationship between the wavelength and the energies. So, basically, what is the formula for energy? If you remember, you all are aware that E is equals to hc by lambda, right? So, here we have been provided with two energy levels. That means I can write E1 is equals to hc by lambda 1 and E2 is equivalent to hc by lambda 2. Yes? Now, let us write the given values. What is lambda 1 and lambda 2? Sorry, they have given us E1 and E2 value. E1 value is 25 electron volt and E2 value is 50 electron volt, right? So now you need to calculate relation between lambda 1 and lambda 2. Let us put the values over here. See, 25 is equivalent to hc by lambda 1, right? So can I calculate lambda 1? Lambda 1 is equals to hc by 25. Similarly, 50 is equivalent to hc by lambda 2. So lambda 2 is basically hc by 50. Relation between what we need to find? We need to find a relationship between lambda 1 and lambda 2. So if I am going to divide both of them, lambda 1 by lambda 2. Lambda 1 is hc by 25 and lambda 2 is hc by 50. So hc got cancelled and this 25 2s are 50. So if I am cross multiplying it, it will be lambda 1 is equals to 2 into lambda 2. Lambda 1 is equivalent to 2 into lambda 2. So which of the following options will be our correct answer? Option number B will be our correct answer. Option number B will be our correct answer. Is it clear to you, students? Kindly let me know if it is clear to you. Yes? Is it clear to you? Kindly write it down so that we can move on to our next question. So students, I hope so. Now you have done this question. Now let us proceed towards the next question. The next question says that the energy of a photon is given as 3.03 into 10 raised to the power minus 19. It is 10 raised to the power, okay? Joules per atom. The wavelength of the photon is, now you have four options. A option is 6.56 nanometer. B option is 65.6 nanometer. C option is 0.656 nanometer, while D is 656 nanometer. So students, I am giving you 2 minutes to solve these questions. You can pause the video and try it out, and then I will be telling you that how we need to solve these questions. Yes. So students, you all are aware with this formula. E is equals to hc by lambda. Yes. So we are going to apply this particular formula over here, and we are going to calculate our answer. So if I talk about h, what is h over here? Planck's constant. What is the value of it? Its value is already provided you in the question. 6.626 into 10 raised to the power minus 34. What is the value of c? C is speed of light. So its value, sorry. So its value will be 3 into 10 raised to the power 8 divided by, now see, here we don't know the value of wavelength. We need to find out the value of wavelength. But yes, we know the value of energy. What is the energy of photon? It is 3.03 into 10 raised to the power minus 19. So we are going to do cross multiplication over here in order to solve such questions. Lambda shall be 6.626 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8 divided by 3.03 into 10 raised to the power minus 19. So when you are going to solve this, you can approximately check the values, like 3 2s are 6, so it can approximately cut on the table of 2, and when you are going to multiply it with 3, you are going to get approximately 6 something. You can see the options, it contains 6 in the starting. Now as you all know, it is NEET, so for NEET you have to save your time rather than consuming it on multiplication. So now what you need to see over here, that 10 raised to the power, what answer will come over here. So what you can do is, you can take this minus 19 over there in the numerator section. It will get add upon there, because whatsoever charge is there in the denominator, it gets changed in the numerator. For example, if it is given as plus 2 in the denominator and you are taking in the upward direction, so it will become minus 2. If it is minus 2 in the denominator, when taken up in the upward position, it will become positive, right? So when you are going to solve it, your answer will come out to be option number D, that is 656 nanometer. Answer will come out to be option number D, right? Now we shall proceed towards the next question. Now let us read the next question of ours. Yes, before on going to the next question, let me tell you one more thing. See, if this if it will go on the upward direction, it will become plus 19. 19 plus 7 is what? 27. Then you're going to solve it, minus 34 plus 27. By this way you'll get it, and then you're going to divide all the zeros that they have, and then you're going to get your answer in nanometers. So it will be 656. Now let us see the next question of ours. What will be the longest wavelength line in the Balmer series of the spectrum? Okay, A option is 546 nanometer, B option is 656 nanometer, C is 566 nanometer, while D is 556 nanometer. Now students, just think once over here that you have to tell what? Over here you have to have longest wavelength line in the Balmer series. Now if you remember, in the Balmer series, when we are talking about longest wavelength, we are talking about lowest energy value. Longest wavelength, lowest energy, right? Sorry. Now you have seen the series Lyman, Balmer, Paschen, right? All of these series. So you know the lower energy value and the higher energy value. The lower energy value, the N2 value for over here will be, higher one will be 3, and the lower one is 2 over here. You all are aware when I am talking about which series? Balmer series. Which series? Balmer. That means electrons will come up to which ground state level when N1 is equals to what? N1 is equals to 2, right? Now what is the formula? What is the formula? 1 by lambda is equals to RH, Rydberg's constant, into 1 by N1 square minus 1 by N2 square. This is our formula that we are going to apply. I guess you all are aware with this particular formula over here. What is the value of Rydberg's constant? It is 109677. This is the value of Rydberg's constant, right? So now here we need to calculate wavelength. So 1 by lambda is equivalent to 109677, right? Into 1 by N1 square. N1 over here is 2. So 2 square minus 1 by, we have now N2, that is 3. Over here students, now when we have written all of these values and when we are going to solve it out, we will get our answer for whom? For lambda. That is for our wavelength. Now when you are going to solve it and you're going to cross multiply it, you'll get your answer in centimeter. Then you need to convert it into nanometer and you shall get your option number B as the correct answer. Option number B will be your correct answer. Great. Can we move on to the next question? Okay. The next question is, according to the Bohr theory, which of the following transitions in the hydrogen atom will give rise to the least energetic photon? Now, I have not solved the part over there in the multiplication section because I want you all to practice as many as questions over here in this short span of time. So, the calculation work I know you can do. I've just given you hint and solution over here that how you have to solve the questions. Okay, the rest of the work I know you will be able to do so fast. And also do remember one thing, like I told you in this previous case, that you have to find approximate value. With the help of approximate value, you can solve the questions. Because in paper, there is no need to solve the complete question, complete answer, 0.2233. No. You just have to see one or two numbers and you will get your answer. You have to see the options, right? Sometimes students, what happens is while seeing the options and applying the options into the question also gives us an answer. So this is also kind of a trick that you can apply whensoever you want to, right? Now the question is, according to the Bohr theory, which of the following transition in the hydrogen atom will give rise to the least energetic photon? To the least energetic photon. What do you think? What do you refer as least energetic photon? Okay. What is least energetic photon? Now the formula of delta E. See, delta E is also directly proportional to 1 by n1 square minus 1 by n2 square, where n2 is more than n1. Delta E, the change in energy, is also directly proportional to this according to our formula, right? So basically, we will see the transition as less, then only we can say that there is least energetic photon. The least energetic photon will be seen when the energy levels are very close to each other. There is no more larger transition. For example, when we are moving from 5th to 3rd, there is a transition level. When we are moving from 6th to 1st, from higher to 1st, there is a larger transition again. From 5th to 4th, and then we have 6th to 5th. So let me tell you that least energetic photon will be seen from 6, and 6 is equals to n5. At this point of time, you shall observe this least energetic photon. Clear? Shall we move on to the next question? If you have done this, kindly write this. Kindly do this so that we can move on to our next question. Sorry. The spectrum of helium is expected to be similar to that of. The spectrum of helium is expected to be similar to that of A is hydrogen, B is Li positive, C is sodium, while D is He positive. So see, if I talk about helium, how many electrons are present in helium? Hydrogen, helium. Atomic number is 2. So if it is a neutral species, yes, electrons are present is 2. Now, let us see other cases also over here. If I talk about hydrogen, neutral species, electrons will be 1. Atomic number is 1. Lithium positive, electrons will be lithium, hydrogen, helium, lithium. Atomic number is 3. For neutral it is 3, but there is a +1 charge, so you will subtract 1, it will become 2. 2 electrons, okay. For Na, atomic number is 11. It is a neutral species, so number of electrons, protons and atomic number will be same. Electrons will be 11. For helium positive, hydrogen, helium, again atomic number is 2, but there is a +1 charge, so you shall subtract 1, you will get 1. So 2 is equivalent to 2 in this option, so that means option number B is our correct answer. Answer will be our option number B. Is it clear to you people? Shall we proceed to the next question of ours? Great. Great. Now comes the next question. If the uncertainty in position and momentum are equal, if the uncertainty in position and momentum are equal, then the uncertainty in velocity is. You have certain options over here. I am giving you 1 minute of time. This is Heisenberg uncertainty principle that is being applied over here. So kindly solve and try this question out. Then I will let you know how to do this. First, try by your own, students. Yes, if you don't know the formula, I can tell you the formula. That is momentum delta P, change in, position, is more than or equal to h by 4 pi. This is the initial formula. If you don't know the formula, I've given you the formula. Now you just have to put the values and find out the answer. Now you just have to put the values and find out the answer. See, change in uncertainty in position and momentum are equal, right? So basically, we can write this delta P as mass into velocity into delta x like this, because if you see the options, they have m also there in between, right? See, if our velocity and this is same, then what is going to happen? If it is same, I can directly write m into delta v whole square is more than or equal to h by 4 pi. Yes, yes, okay. Then see what will happen in this particular case. We will take this m over here, it will become delta v whole square is more or equal to h by 4 pi into m, right? Now we have this whole square, this will become root, so it will be delta v more or equal to is equal to h by 4 pi m, and we have a root over here. So this is delta v more or this equal to, now m over here is constant, right? M over here is constant, mass is constant, so it will come out 1 by m. Also root 4, so it is 2 will come out, and under root we will have h by pi. So this is going to be our uncertainty in velocity. You might be thinking that why I have opened this, because we have to find the uncertainty in velocity. So uncertainty in velocity is 1 by 2m root h by 4 pi. 1 by 2m root h by 4 pi. That means option number A will be our correct answer. Option number A will be our correct answer. Clear? Clear? Can we move to the next question if you have done this? Shall we move on to the next question? Great. Now students, see, the next question basically is, the uncertainty in measurement of an electron is this much. The uncertainty in position will be what? Uncertainty in measurement is given to you, but you need to find out the uncertainty in position. Now this is the same formula question, same formula based question, and I want you all to find its answer. Same formula based question. What is the formula, ma'am? Delta x into delta p is equals to h by 4 pi, right? See, the uncertainty in measurement of an electron is this much. Uncertainty in position will be what? Delta x you need to find out. Here it is not measurement, here momentum will come, okay? So delta x into, it is 1 into 10 raised to the power minus 5 is equals to h. What is the value of h? It is 6.62 into 10 raised to the power minus 34 divided by 4 into pi value 3.14, right? So when you're going to cross multiply, it shall be delta x is equivalent to 6.62 into 10 raised to the power minus 34 divided by 4 into 3.14 into 10 raised to the power minus 5. 10 raised to the power what? Minus 5. So now students, when you are going to calculate it, you are going to get your answer. Now again we have to see the approximate answer over here. Let us consider that this 3 2s are 6, so it will be on the table of 2. 2 2s are 4, down we will get 2 at the denominator. Now you will divide 2 with 10, it will come 5 point something. So now if you see, if you observe this over here, it will come out to be 5 point something, right? When you will take this over there in the above, it will become plus 5. First of all, it will become plus 5 something. We solve it out, okay? Shall we solve it out? Let us consider it is 6.6, it is 3.1 on the table of 2, I have divided it. Then 2 2s are 4, then it is again divided. Delta x is equivalent to 10 raised to the power minus 34. This is approximate answer that I am showing you. Plus 5 divided by 2. This is 10 raised to the power minus 29 by 2. I can write it as, I can write it in such a way that 1 by 2 into 10 raised to the power minus 29. So it is 0.5. Approximate answer I am telling you, 0.5 into 10 raised to the power minus 29. So I can write it as 5 into 10 raised to the power minus 28. Approximately we'll get this answer. Approximate answer that I can tell you. Great. Okay. Now let us move on to the next question of ours. The next question is, 4d, 5p, 5f and 6p orbitals are arranged in order of decreasing energy. The correct option is, now you have to tell the correct option. You have to tell the correct option. You have to find out the correct option for this. 1 second, students. Yeah. So you have to tell the correct option. 4d, 5p, 5f and 6p orbitals are arranged in order of decreasing energy. Now see, here you have to apply which rule? Of-bow principle. Do you remember of-bow principle, students? See, more the value of n plus L, more will be the energy. More the value of n plus L, more will be the energy. Now let us apply in this particular question. We have 4d. First of all, see 4d. What is the value of n over here? N is 4. See, for this also I shall write over here 0 for S, 1p, 2d, 3f. This is the value of L. This is the value of L. Value of L. Now see over here. N is 4, L over here for D is 2. Okay. 4d, then we have 5p. N over here is 5 and L over here for P is 1. Then we have 5f. N over here is 5 and L over here for F is 3. Then we have 6p. N over here is 6 and L over here is 1, right? Now over here see N plus L over here. N is 4, L is 2, it is 6. N plus L over here. N is 5, L is 1, again it is 6. Over here N plus L. N is 5, L is 3, that is 8. Then we have N plus L over here. N plus L, that is 6 plus 1, that is 7. Right? Now you have calculated the value of N plus L. Yes, students, tell me. Do you have calculated the value of this? Yes. So which has more value? 8 1. That is 5f. 5f will have more value. So it is in this option and this option. Then we will have 6p because it has 7 value, 6p, 6p. Now see, both of them has the value of 6. So you should see over here when n plus L, now listen to me very, very carefully. Very, very carefully. When n plus L value is same, you need to see the value of n. Lower the value of n. Low is energy. So in both of these cases, n value here is 5, here is 4. Here n value is low, so it will have low energy. That means after this 5p will come. And then 4d. That means option number B is going to be the correct answer. Option number B is going to be your correct answer. Again I am saying, lower the value of n, lower will be the energy. So this will have more energy. That means 5p will have more energy. Great. Can we move on to the next part? Yes, students. Tell me fast. Shall we move on to the next question? Tell fast. Is it clear? Okay. Now comes the next question. How many electrons can fit in the orbital for which n is equals to 3, L is equals to 1? N is equals to 3, L is equals to 1. A option is 2, B option is 6, C option is 10, D option is 14. Now think about this question very carefully. Think about this particular question very carefully, students. How many electrons can fit in the orbital? I am giving you 2 minutes of time in order to solve this question. It is very simple. First of all, identify what is the value of n. Then put n value in front of S, P, D, F, what you ever feel like while looking up to L. Just right now I have told you, L value, if it is 0, it is S. If it is 1, it is P. If it is 2, it is D. If it is 3, it is F. Yes, okay. Yes, okay. So over here, see. L value is what? That means it is P. P. Okay. N value is what? 3. So it is 3p. They are asking you how many electrons can fit in the orbital. Now, how many electrons are filled in p orbital? Ma'am, p orbital is basically is like this. So 1 electron, 2 electron, 3 electron, 4 electron, 5 electron and 6 electrons, ma'am. Total 6 electrons can be filled in 3p. Hence, answer will become to be B option. Answer will come out to be B option. Is it clear to you people? Yes, my dear students. Tell me fast. Is it clear to you? Shall we move on to the next question if it is done? Can we move to the next question if it is done? Okay. Okay. Now comes the next question. That is, which of the following pairs of d orbital will have electron density along the axis? Which have electron density along the axis? A option is dx square dxz. B option is dxz dyz. C option is dx square y square. While D option is dxy dx square y square. Now see over here. If I talk about d orbitals, understand this. D orbitals are basically of two kinds. That is one along the axis, one that lies along the axis, and another one that lies that lies in between the x's. That lie in between the x's. Now see, the one that lie in between the x's is, one of the example is this one. If it is x, it is y. This is dxy. Okay. If it is y, it is z. And the lobes lie in this way. See, for d orbital, they are double. So this is dyz. If it is y-axis, if it is x-axis and it is z-axis, and the lobes lie in between the x's like this, this is dxz. So these are the one that lie in between the x's. While if I talk about the one that lie along the axis, is if it is x-axis, it is y-axis, and the lobes lie in such a way on the axis this way. So this is dx square y square. This is dx square y square. One more I'll show you over here. For this one, let us consider this is your z-axis. So the lobe is lying in such a way that one will present like this and one will present like this. Clear? So this is your present on the z-axis. So this will present in such a way. This is said to be dz square. This is said to be dz square, right? So now these are the one that lie along the axis, that means on the axis, and these are the one that lie in between the axis. So they said that which of the following pairs of d orbital will have electron density along the axis. Along the axis are dx square y square and dz square. Dx square y square and dz square. Here you can correct it, it is dz square. So option number C is going to be correct answer. Kindly correct it. It is a printing mistake over here. It is dz square. Is it clear to people? Yes, students. Shall we move on to the next question of ours if it is done? Yes. Can we move on to the next question of ours? Okay, one thing students, in this particular question, yes, 1 second. In this particular question, coming back to this question, the question say how many electrons can fit in the orbital for which n value is this much. They are saying how many electron can fit into the orbital. Okay. See, if I talk about a particular 3p orbital, so one orbital can contain 2 electrons. If they are asking you total electrons present in p subshell, that is 6 electrons. So here answer will be option number first, that is 2 electrons, because they are asking you in a particular orbital of 3p, in the orbital for which this is given to you, not a subshell they have said you. Great. Now comes the next question. 2 electrons, this one is done, no? Yes, okay. Next question is, 2 electrons occupying the same orbital are distinguished by. 2 electrons occupying the same orbital are distinguished by. A option is azimuthal quantum number. B option is spin quantum number. C option is principal quantum number. While D option is magnetic quantum number. Now you need to tell that how 2 electrons can be distinguished. On which of the following property they can be distinguished. Yes, students. I guess now this is the question that is a kind of a theoretical one and you all are aware of this particular question as well. Yes? Okay, do you know this thing? N, L, M, S. They can be same, but S can never be same. Why? Because it can either be plus half or it can either be minus half. Now, what is this plus half, minus half? This is rotating in clockwise direction or rotating in anti-clockwise direction, right? So, any electron, you know, there can never be same condition. They 3 can be same, but S cannot be same when these 3 are same. So spin quantum number is the one that with the help of which we can distinguish 2 electrons. With the help of which we can distinguish the 2 major electrons. Is it clear? Is it clear to you people? Okay, now moving on to the next question. Which is the correct order of increasing energy of listed orbitals in titanium when Z is equals to 22? Now, first of all, write the electronic configuration. Giving you a minute, write the electronic configuration fast so that I can tell you that which of the following is in increasing energy. Now, increasing energy we can also do as N plus L value, in the form of N plus L value. Yes, students, kindly do it fast. See, Z is 22. Sorry, atomic number is 22. For whom? For titanium. So how we will fill electrons? 1s2, 2s2, 2p6. How many electrons? 2 plus 2, 4. 4 plus 6 is 10. Okay, now 3s2, 12. Now what will come over here? 3p6 again. So it is 2 plus 2, 4. 4, 10, 12. 18. 18 are filled. How many are left? If 18 are filled, 4 are left, right? So it is 3p, 4s2. Again 2 are left. Again 2 are left. Yes, students. So now 3D will come. It is 3D2. Yes. Yes, students. Everybody has written the same electronic configuration as I have done. Everybody has done the same way. Count the electrons if you feel like. 2 plus 2, 4. 4 plus 6 is 10. 10, 12. 12, 18. 18 to 20, 22. Clear? Now we have to write what is the correct order of increasing energy. See, more the value of N plus L, more is energy. Yes. So if I talk about, first of all, let us talk about, we'll do for everyone. For, they have taken 4s, 3s, 3p, 3d. Okay, they have taken from these values. This is same, they have taken from that. Okay, they have not included these, so they have told with that. If I talk about 3s, N value over here is 3, L value over here is 0. Again, I am writing over here. L is 0 for S, 1 for P, 2 for D and 3 for F, right? So, for the next case we have 3P. N value is 3 over here and L value, P value is 1 over here. Then we have 4S. N value is 4 over here, S value is 0. Then we have 3D. N value is 3 over here, L value is 2 over here, right? So now we are going to see the N plus L value. L plus L value. Over here, N plus L value is 3 plus 0 is 3. Over here, it is 4. Over here, it is again 4. Over here, it is 5. So, the higher energy will be of 3D. 3D at last, 3D at last, 3D at last. This is incorrect. Increasing order, that means lower, 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 then higher, right? Though I have written the electronic configuration according to above principle only, but I want that it should be clear to you people. That's why I've written this again. Though you can directly tell me the answer from this. Directly. Yes? Okay. So see. Again they have 4 for value. Lower the value of N, lower will be the energy. This is the lower value. So this will have lower energy in comparison to 4S. So 3P has lower energy than 4S. Right? So after 3D, this will have more 4S. 4S. That means option number C is the correct answer. Then 3P and at last 3S will come. Is it clear to you people? Kindly write it down so that we can move on to the next question. Okay. Now comes the next question. What is the maximum number of orbitals that can be identified with the following quantum number? What is the maximum number of orbitals? Now see over here. N value is 3. That means, see, over here, L value is 1, M is 0. So L value, it is 0, it is S, 1, it is P, 2, it is D, 3, it is F. N value is 1, that means P will come. N is 3, so it is 3P. It is what? It is 3P. Yes, it is clear to you people. It is what? Ma'am, it is 3P. Yes, okay, you are getting my point that it is 3P. But what we have to find in this particular question, just read the question all over here again. They have said, what is the maximum number of orbitals? Now, what is the role of M, ma'am? See, P orbital is like this. 1 orbital, 2 orbital, 3 orbital. 1 orbital, 2 orbital, 3 orbital. Do you know what is M? M is minus L2 plus L. What is the value of minus L? L is minus 1, so minus L2 plus 1. This is minus 1, 0 and plus 1. That means this is minus 1, 0 and plus 1, right? This is the value of M. M can be calculated as minus L to plus L. Minus L to plus L. L over here is provided to us as 1. So I can say minus 1 to plus 1. That means minus 1, 0 plus 1. Minus 1, 0 plus 1. M is 0. If M is 0, how many orbital is there in 0? Only 1. So our answer is going to be option number A. Answer is going to be option number A. Is it clear to you people? Is it clear to you people? Can we move on to the next question of ours? Yes? Okay. Now let us see the next question. Maximum number of electrons in a subshell with L is equals to 3 and N is equals to 4 is. Maximum number of electrons in a subshell with L is equals to 3 and N is equals to 4 is. Now see over here again. L when it is 0 it is S, when it is 1 it is P, when it is 2 it is D, it is 3 it is F. Now here L is 3, that means it is F. Now we have N value as 4, then it means it is 4F. You have to tell maximum number of electrons in a subshell. Maximum number of electrons in a subshell. In F we know it is 7, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 and 7. How many electrons can be filled? If in 1 if only 2 electrons can be filled, then in 7 how many electrons can be filled? 14. So option number A is correct. Now you can compare with the previous question. I guess now you are able to compare with the previous question just as we did in the previous question. In the previous question they were asking about the orbital. It was asking about the orbital, but over here it is asking about a different scenario. Yes students, in the previous question it was asking us about the orbitals, but over here in this particular part they are asking us about in a subshell. So in orbital it was basically we have seen 2, over here it is in complete. The orientation of an atomic orbital is governed by, the orientation of an atomic orbital is governed by what? Now you have 4 options: principal quantum number, azimuthal quantum number, spin quantum number and magnetic quantum number. Now students, this is a theoretical kind of question. I expect that everyone knows this answer. Now I expect that everyone knows this answer. This shall not be taken more than 2 minutes, right? More than few seconds in fact. Orientation. So basically students, if I talk about what do you refer to as principal quantum number, we have just done all these concepts, right? We have already done these concepts, right? Many of the students will answer spin quantum number, but let me tell you that tells about the spin, about the direction, clockwise or anti-clockwise. Here they are saying about the orientation, not about the direction. So the orientation is identified by magnetic quantum number. Many of the students knowing this answer will get the answer wrong. Magnetic quantum number tells us about the orientation, while the spin ones tells about the direction, whether it is anti-clockwise or it is clockwise. Now moving on to the next question. In a given atom, no 2 electrons can have same value for all the 4 quantum numbers. This is called. Now see, I have told you why they can't have all the 4 same values. See over here, it can have N value same, L value same, M value same, but S cannot be same. So no 2 electrons can have all the values same because their S will be different. Either their S can be plus half or it can be minus half, hence it will be different, right? So for this case, which law has proved this? A option is Hund's rule, B option is off-bow principle, C option is uncertainty principle, while D is Pauli exclusive principle. So yes, do let me know what will be the answer. What will be the answer for this? Now all of these questions are taken from the previous year. You can even mark them. You can even check them. It will be easy for you to understand, right? So students, see, if I talk about Pauli exclusive principle, it is the principle which said that all the 4 electrons, all the 4 basically these quantum numbers, you know, if I talk about principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, they cannot be same for 2 electrons. That was said by Pauli exclusive principle. I guess now this is clear to you. Yes students, can we move on to the next question if it is done? Yes, shall we move on to the next question if it is done? The next question is, for azimuthal quantum number, okay, for azimuthal quantum number L is equals to 3, the maximum number of electrons will be. When azimuthal quantum number, they have given you L is equals to 3, you need to tell the maximum number of electrons will be. So see, again, L when it is 0, it is S, when it is 1, it is P, it is 2, it is D, if it is 3, it is F. Now that means it is which orbital? F orbital. They are saying maximum number of electrons will be. So for F, when it is L is equals to 3, it is 14 electrons. One orbital contain 2 electrons. 7 orbital will contain how many electrons? 14 electrons. How many electrons, students? 14 electrons. I guess this is now clear to you. Okay. Shall we move on to the next question of ours if it is done? Yes, students. Okay. Now I shall read the next question for you all. The number of spherical nodes in 3p orbital is. The number of spherical nodes in 3p orbital is A option 1, B is 3, C is none, D is 2. Kindly do this question very fast because the next two questions are done on the nodes itself. The next two questions lies on the nodes itself. Spherical nodes. Yes, students, have you done this question? Have you done this question? Okay, what is the formula for total nodes? What is the formula for total nodes? Total nodes is n minus 1. What is the formula for angular nodes? Angular nodes is L. And what is the formula for spherical nodes? If you remember these two formula, total nodes is automatically remembered. You're going to add them all together. Now see, we have 3p. This number represents n. N over here is what? N over here is 3. N over here is 3. What is p value? What is p value over here? Now see. Again, you know this thing that what is the value of L? Sorry, what is p value I am writing? What is the value for L for p? Again, L if it is 0, it is S. If it is 1, it is P. If it is 2, it is D. If it is 3, it is F. For P, L is 1. Right? Now, N you have got, L you have got. Calculate all of these number. Total nodes is N minus 1. What is N? 3. So, 3 minus 1 is 2. Okay. Now comes angular nodes. Angular nodes is L, that means it is 1. Now comes spherical nodes. Spherical nodes is N minus L minus 1. So N over here is 3 minus L is 1 minus 1. That means it is 1. That means it is 1. Yes, students. Is it clear? If it is clear, so let me know. The number of spherical nodes will be 1. The number of spherical nodes will be 1. If it is clear, then we shall proceed towards the next question. If it is done. Okay. Now I shall give you one more question based upon the spherical nodes and then we will wrap up our today's segment. Okay. For spherical nodes, let me bring one question for you. I've already taken that question out. It is also a previous year question. Orbital having 3 angular node and 3 total node is. Orbital having 3 angular node and 3 total node is. Okay, your options are 5p, 3d, 4f, 6d. 5p, 3d, 4f and 6d. This is also one question based upon the nodes. Now see, three angular nodes. Angular nodes. Angular node is L. Just written over here. Angular node is L. Right? Spherical node is N minus L minus 1. And what is total node? Total node is their addition. That is N minus 1. Now what is the values given to you? Angular node is 3. That means L is 3. Total node is 3. So it is N minus 1 is equivalent to 3. N is equals to 3 plus 1, because on other side it will become plus. N will come up to be 4. If N is 4, L will be 3. L will be 3. So L, if it is 0, it is S. If it is 1, it is P. If it is 2, it is D. If it is 3, it is F. If it is 3, it is F. So over here, L value is 3. 3. That means it is F. So our answer will be what? Our answer will be 4F. Our answer shall be what? 4F. Yes? Is it clear to you people? Kindly write it down, students, so that we can end our today's session over here. Before ending, students, there are some few lines for you people. Now I have covered each and every question, each and every topic segment over here, right? So before ending the session, as you all are preparing for your NEET examination, and NEET examination is very close and you all are very scared, let me tell you students, these are previous year questions, are the most important questions for you people. If you are able to solve it, it's good, but if you're not able to solve it out, then you need to analyze yourself, that where you are lacking, which concept you need to practice more rather than crying. So don't cry, pick that topic again and do your work, and I know you will succeed. These all are previous years, so you can see the level of questions they are asking in the question paper. You can know and you can identify yourself, analyze yourself and work on it. So before ending, there are few lines for you people. Think smiles and smiles shall be. Think doubt and hopes will flee. Think love and love will grow. Think good and good is here. Think vice, its jaws appear. Think joy and joy never ends. Think gloom and dusk descends. Think faith and faith is in your hand. Think ill, it stalks the land. Think peace, sublime and sweet, and you will meet your peace. Think fear with brooding mind. Think fear with brooding mind, and failures close behind. Think this, I am going to win. Think this, I am going to win. Think not on what has been. Think not on what has been. Think victory, think I can. Think victory, think I can. Then you are a winning man. Then you are a winning man. You are my winning shimmering stars, and you have that potential. So trust yourself, because your teacher trusts you, right? So we shall meet in the next lecture with the next chapter. So cover up your chapters with the previous year questions and the most important question. Take it as a practice session. Take it as a challenge and keep moving further. Thank you so much, students. Have a good day. Keep smiling. Keep learning.